Hello there. Welcome to Drifting Off Learning Channel. You have arrived at exactly the right moment, in exactly the right place, and there is absolutely nothing you need to do right now, except allow yourself to settle. Let the weight of your body sink a little deeper into wherever you are resting. Feel the surface beneath you, the softness or the firmness of it, the gentle, reliable way it holds you without effort or asking anything in return. You do not need to hold yourself up right now. The world is doing that for you, steadily and quietly, the way it always has. Take a slow breath in and then let it go without rushing, letting the air find its own gentle pace as it leaves. And again, slowly, without any urgency, breathing in a little of the quiet that surrounds you right now, and then releasing it back, letting your chest soften, letting your shoulders drop just slightly. There is nothing to carry tonight. You can set it all down. The day is finished now. Whatever it held, whatever it asked of you, whatever you were thinking about just a little while ago, all of that is behind you, receding gently the way the light recedes in the evening, quietly and without fanfare. The evening belongs to rest, and rest belongs to you, as naturally and as freely as sleep has always come to every living thing since the very beginning of life on this earth. So let yourself settle here, in the soft space between wakefulness and sleep, and allow these words to wash over you the way shallow water washes over smooth stones on a quiet shore. You do not need to hold on to anything that is said here. You do not need to remember or to follow or to understand. These words are only here to keep you company as you drift, gently and without hurry, toward the deep, still place where sleep is waiting for you. And if you find something here that interests you, something that feels like a small, warm light in the dark, perhaps you might consider keeping this channel close. A soft place to return on other quiet evenings. You are always welcome here. Now, let us begin. The earth beneath you, beneath this building, beneath this city or this field or this quiet neighborhood, is moving right now. It has never stopped moving since the very beginning, not once in 4.5 billion years, and yet you cannot feel it. The motion is so vast, so perfectly smooth, so immeasurably ancient that your body registers it as stillness. You are turning away from the sun right now at roughly 1,000 miles per hour at the equator. A little slower here depending on where you are in the world, and the darkness gathering outside your window or beyond your walls is simply the natural shadow of your own planet, sweeping gently across the face of the land the way a soft cloth sweeps slowly across a table. It is not the absence of the sun. The sun has not moved. It is only that the earth has carried you tenderly and reliably around to the other side, where the night lives, where the quiet lives, where rest has always been waiting for the living things that need it. This has happened without exception every single day of your life. Every morning that you have ever woken up, every evening that you have ever settled down to sleep. This same rotation has been carrying you, unhurriedly and without fail, through light and back into dark. The rhythm of day and night is perhaps the oldest rhythm you have ever known. You knew it before you knew anything else. Your body learned it before you could speak, before you could think in words, while you were still very young, and the world was still very new to you, and your body has never forgotten it. The rhythm lives in you the way it lives in every living thing, in the cells, in the chemistry, in the quiet ticking of biological clocks that have been keeping time since long before clocks were invented. Somewhere in the depths of your body, there is a cluster of neurons, very small, sitting just above the place where your optic nerves cross, and these neurons are keeping time. They have been keeping time your whole life. They are the reason you feel sleepy at night and alert in the morning. Not because you decided to feel that way, not because of effort or discipline, but because the biology of your body has been synchronized over an entire lifetime with the turning of the earth. You are, in a very real and beautiful sense, a creature of this planet's rhythm. The earth turns, and you sleep. The earth turns again, and you wake. There is a deep harmony in that, something worth resting inside of. The name for this inner timing is a circadian rhythm, from the Latin words meaning roughly around the day. And while the phrase is modern, the rhythm itself is ancient beyond imagining. Single-celled organisms living in the ocean 3 billion years ago already had something like this rhythm. Life, from its very earliest moments, learned to keep time with the turning of the planet. It learned that the light brings one kind of chemistry, and the dark brings another, that there are things best done in the warmth of the day, and things best done in the quiet of the night. Sleep itself is one of those night things, one of those deep, essential, ancient things that the darkness calls forth in living creatures the way the tide calls water up the shore. The ocean, right now, is also keeping its own great rhythm. Somewhere far from wherever you are, the sea is breathing in long, slow cycles that have nothing to do with weather and everything to do with the moon. The tides are rising and falling, pulling in and drawing back, all around the coastlines of the world, following the gentle gravitational conversation between the Earth and its only natural satellite. The moon, drifting through its own slow orbit some 250,000 miles away, tugs at the ocean with a force so steady and predictable that navigators have been able to calculate the tides centuries in advance. The ocean does not resist this pull. It simply answers, the way a sleeping person answers the call of comfort, by moving toward it, softly and without resistance. The moon itself is in a rhythm. It takes just over 27 days to orbit the Earth, and just over 29 days for the cycle of its phases to complete. The slight difference arising from the fact that the Earth itself is moving around the Sun, while the moon moves around the Earth. So the moon must travel a little farther each month to appear full again from our perspective. These two numbers, so close and yet slightly different, have been the basis of human calendars for thousands of years. Ancient people watched the moon the way we might watch a clock, knowing that its swelling and dimming, its rising a little later each night, its silvery fullness and its invisible absence were all part of a great, dependable cycle. They felt safe inside that cycle. They organized their planting and their harvest, their festivals and their fasting, their rituals of birth and burial, all according to the turning of the moon. There was comfort in its predictability, comfort in knowing that even the dark nights were temporary, that the light would slowly return. Outside right now, if the sky is clear, the stars are doing what they have always done, appearing to wheel slowly overhead in great arcs, rising in the east and setting in the west, following the same path they have traced every night since the earth was young. Of course, it is not the stars that are moving. It is you, carried on the turning earth, passing through the darkness with your face tilted up toward infinity. The stars themselves are almost incomprehensibly far away, and moving in their own directions through the galaxy at speeds that make human transportation seem impossibly slow. And yet from here, From the surface of this small turning world, they appear fixed, still reliable, like lanterns hung in a ceiling that has never changed. People have been navigating by those stars for tens of thousands of years. They have been using them to find north and south, to predict the seasons, to know when to plant and when to rest, and the stars have never failed them. Not once. The sky has always turned. The constellations have always risen and set. The pole star has always sat quietly above the northern horizon, barely moving while everything wheels around it. There is a particular star that barely moves at all from our perspective, sitting very close to the north celestial pole, and it has been a steady companion to anyone who has ever needed to find their way in the dark. But it has not always been the pole star. Because the Earth is not a perfect sphere, it wobbles very slightly as it spins, the way a top wobbles when it begins to slow, and over a period of roughly 26,000 years, this wobble causes the North Pole to trace a great, slow circle through the sky. 26,000 years ago, a different star sat near the northern pole. In 12,000 years, a bright and beautiful star called Vega will take the role. And in another 26,000 years, the sky will return to where it is tonight. It is a cycle so vast that not a single human civilization has lived long enough to see it complete. And yet it is as real and as regular as the turning of the seasons. The earth is always moving in its stately, unhurried way, and all the rhythms we can see are only the visible surface of rhythms, far older and far deeper than we can hold in our minds all at once. The seasons themselves are a rhythm that lives in the body as well as in the world. As the earth moves through its year-long journey around the sun, it is tilted at an angle of about 23.5 degrees from straight upright. And it is this tilt, more than the distance from the sun, that gives us our seasons. When your part of the world is tilted toward the sun, the days grow long and the light falls more directly, warming the ground and coaxing life upward. When your part of the world is tilted away, the sun sits lower in the sky, the days grow short, the light falls at an angle and carries less warmth, and the world quiets itself down, pulling inward, slowing down, conserving energy, resting. It is a planetary version of what you are doing right now, drawing inward, settling, letting the busy work of the day give way to the deep quiet of the night. The tilt of the earth has never changed significantly in any human time frame. It drifts very slowly over tens of thousands of years, but within any single human life, within any 100 human lives, it is essentially constant. And so the seasons return. Spring follows winter as reliably as morning follows night. The trees know this. The birds know this. The bears in their dens know this, dreaming through the cold months with a biochemistry perfectly tuned to sleep, their hearts beating only a few times per minute. Their body temperature dropped, their metabolism slowed almost to stillness, waiting with perfect patience for the warmth that is always coming. They do not worry whether spring will return. Something in their cells simply knows that it will, and they rest inside that knowing, completely and without reservation. The sleeping of a bear through the long winter months is one of the deep, slow rhythms of the mammalian world. But there are slower rhythms still. The great forests of the world breathe in a cycle that takes years, sometimes decades, sometimes centuries to complete. A tree in the boreal forest of Canada may live for several hundred years, and in that time it will participate in rhythms that move far too slowly to perceive from day to day. It will grow slowly through the long northern summers, adding only a thin ring of wood each year, a ring so thin you could barely see it without a lens. And yet, after a century, those rings will tell a story of every drought, every wet year, every cold summer, and every warm one. A detailed autobiography written in wood. The rings of ancient trees have been used to reconstruct the climate of the past thousands of years, to understand the rhythms of the sun, and the patterns of rainfall, and the slow pulsing of warmth and cold that have shaped the living world long before any human was there to observe it. In the deep places of the ocean, there are rhythms so slow that they make seasons seem like a rapid drumbeat. The great ocean circulation, sometimes called the thermohaline circulation, or more poetically, the ocean conveyor belt, moves cold, salty water from the surface of the North Atlantic down into the deep ocean and slowly through the global basin, eventually returning to the surface thousands of years later. The same water that now lies silent and cold at the bottom of the Pacific Ocean may have last seen the sky during the height of the Roman Empire. It carries heat and salt and nutrients on this immense millennial journey, regulating the temperature of the continents, feeding the upwellings that nourish the most productive ocean ecosystems on Earth. And it does all of this without any mechanism, without any motor or pump, driven only by the subtle differences in the density of water at different temperatures and salinities. It is one of the great silent engines of the living planet, turning so slowly that it is invisible from any individual human perspective. And yet it has been turning for millions of years, and everything alive on the surface of this world depends upon it in ways too complex to fully trace. Right now, as you rest, you are breathing in rhythm. Not a rhythm you chose, not a rhythm you are directing, but one that your body chose for itself long before you were born, and has been maintaining ever since without a single conscious instruction from you. The diaphragm is a dome-shaped muscle sitting just below the lungs, and it contracts and releases, contracts and releases, about 12 to 20 times per minute when you are awake and somewhat more slowly when you are resting toward sleep. With each contraction, it pulls the floor of your chest cavity downward, creating a slight vacuum that draws air in. With each release, it rises again, and air flows softly back out. You have done this perhaps 600 million times in your life, perhaps more, and you will never need to think about it once. Your brainstem, the oldest and deepest part of your brain, the part that was essentially the whole brain of your very distant ancestors, monitors the chemistry of your blood and adjusts your breathing accordingly, speeding it up during exertion, slowing it during rest, deepening it when carbon dioxide builds, never failing, never forgetting, keeping the rhythm of breath through sleep and waking, through stillness and movement, for as long as you live. Your heart is keeping another rhythm right now, equally automatic, equally ancient, equally reliable. It has beaten somewhere between 2 and 3 billion times since the day it first began beating, when you were still a tiny cluster of cells in the earliest weeks of your life. It was beating before you had a brain. It was beating before you had limbs or eyes, or any of the features that make you recognizable as you. The heart begins its rhythm with remarkable autonomy, driven by its own internal electrical system, a cluster of specialized cells in the upper right chamber that generate a small electrical impulse at regular intervals, sending a wave of contraction rippling through the heart muscle and squeezing the blood forward, into the lungs, and then out into the great branching rivers of the circulatory system. Right now, as you lie still and restful, that rhythm is slowing. The heart rate at rest drops lower than it is during waking activity, and during deep sleep it slows further still. The body knows how to rest. It has always known. These rhythms inside you, the breath, the heartbeat, the slow churning of digestion, the cycling of hormones through the bloodstream, are all in gentle conversation with each other and with the world outside. The light that fell on your eyes this morning began a cascade of chemical signals that has been slowly shifting all day long, moving from the alerting chemistry of morning toward the restful chemistry of night. As the light faded this evening, a small gland at the very center of your brain, the pineal gland, began releasing melatonin into the bloodstream. Melatonin is sometimes called the hormone of darkness, not because it is a dark thing, but because it is a messenger of the night, a gentle signal that says the light has gone, the turning has brought us to the quiet side of the planet. It is time to rest. Animals use melatonin too. It is one of the oldest hormonal signals in vertebrate biology, deeply ancient, shared across an enormous range of living creatures. When the pineal gland releases melatonin into your blood, it is sending the same message that the turning of the earth has been sending to all living things for hundreds of millions of years. The darkness has come. Let go. Sleep. The trees outside, if there are any trees near you, are in their own quiet overnight state right now. During the day, they were performing the extraordinary chemistry of photosynthesis, capturing photons of light and using that energy to transform carbon dioxide from the air and water from the soil into sugar, into the organic carbon that is the substance of all their wood and leaf and root. But at night, photosynthesis stops. The stomata, the tiny pores on the undersides of leaves, close to prevent water from escaping into the dry night air. The leaf canopy droops very slightly in some species, a phenomenon called nyctinasty, the closing of the day. The tree is not asleep in any neurological sense. It has no nervous system, no brain, no consciousness that we are aware of, and yet it follows the rhythm of the light and the dark in its own biochemical way, pausing its active work during the night hours and resuming when the light returns. Some trees move in ways that are measurably different between day and night. Swedish researchers using laser scanners have found that the branches of birch trees droop slightly during the night and rise again in the morning, the droop beginning a few hours before sunrise and the rise following the onset of light, suggesting that the trees are tracking the day-night cycle in some internal way, even before the sun appears. It is not exactly sleep, and yet it rhymes with sleep. The whole living world, it seems, learned very early to honor the rhythm of the turning earth, to have a day face and a night face, a doing time and a resting time, and that wisdom has been passed down through 3.5 billion years of life on this planet, unbroken and uninterrupted. From the first light-sensitive molecules in the first ancient cells all the way to the body you are resting in right now. The soil beneath any garden, any meadow, any forest floor is alive with its own rhythms that we almost never think about. A single teaspoon of healthy soil can contain more living organisms than there are human beings on the face of the earth. Most of these are bacteria, but there are also fungi, protozoa, nematodes, and countless other forms of microscopic life, each living and dying and decomposing and being consumed and reborn in cycles so fast and so small that they are effectively invisible to us. And yet collectively they are performing one of the most important services on the planet, turning dead organic matter back into living nutrients, returning to the soil the elements that plants will take up through their roots and build into leaves and seeds and fruits. The cycling of carbon and nitrogen and phosphorus through the soil is a rhythm that underpins all terrestrial life, a kind of deep breathing of the land itself, endlessly transforming death into new life, breaking down the elaborate structures of once living things into their simplest chemical parts, and offering them back to the beginning of the cycle. It is a kind of generosity, a continuous giving back that has been sustaining the living world for eons. Even the rocks are part of a rhythm, though the rhythm is so slow that no individual human life can see more than the tiniest fraction of it. The rock cycle moves limestone and sandstone and granite through the interior of the earth and back to the surface, through mountain building and erosion and sedimentation and the slow, grinding subduction of one tectonic plate beneath another. A grain of sand on a beach today may have been part of a mountain 50 million years ago. That mountain may have been lifted from the floor of an ancient sea. The seafloor may have been built from the accumulation of tiny marine organisms over tens of millions of years. Organisms whose shells settled slowly and continuously onto the floor of a warm, shallow sea in a world that would be unrecognizable to us. Time moves differently in geology. The same events that happen in a heartbeat in human experience. The settling of dust, the crumbling of a rock face, the deposition of a thin layer of silt. Take thousands or millions of years when worked at the scale of the whole planet. And yet they add up. They accumulate. And the result is the world we are standing on and lying down upon right now. A world that has been in continuous, patient transformation for longer than the mind can comfortably imagine. There is something restful in thinking about deep time. Not because it makes our own short lives seem insignificant, but because it places them inside something so vast and so continuous that all urgency dissolves. Whatever was worrying you today has existed for the blink of an eye in the story of this planet. The Earth was here before any of your worries, and it will be here long after. And it has always been this beautiful, turning, rhythmic, living system, caring for all the things that live upon it in the only way it knows how, by providing the light and the darkness, the warmth and the coolness, the oxygen and the water, and the gravity that holds everything close, reliably, repeatedly, without asking anything in return. The atmosphere above you right now is doing something rather wonderful. It is circulating in great patterns driven by the unequal heating of the Earth's surface. The tropics absorbing more sunlight than the poles, the land heating faster than the sea, the mountains forcing air upward, and the valleys drawing it down. These differences in temperature create differences in pressure, and pressure differences create wind, and the winds of the earth follow patterns so regular and so ancient that sailors named them centuries ago and navigated by them across entire oceans. The trade winds blow steadily toward the equator, deflected westward by the spinning of the earth. The westerlies blow across the middle latitudes. The polar easterlies drift away from the poles. These great rivers of air carry moisture from the ocean over the land, releasing it as rain that fills the rivers and refreshes the groundwater and keeps the forests green. They carry warmth from the tropics toward the colder regions, moderating temperatures and making the higher latitudes habitable. They carry the dust of the Sahara all the way across the Atlantic Ocean to fertilize the Amazon rainforest. The atmosphere is one continuous, interconnected system. breathing, and circulating in patterns that have been established for millions of years. And it is doing all of this right now, quietly, outside your window, above the roof, spreading out into the darkness in all directions as far as the sky reaches. The sky is never entirely dark, even on a moonless night far from any city. The upper atmosphere glows faintly with a light called air glow, produced by chemical reactions involving oxygen and sodium and other elements that have been excited by sunlight during the day, and release that energy slowly through the night as a very dim, diffuse luminescence. Astronauts looking down at the Earth at night can see this glow as a thin, gossamer veil around the planet, almost too faint to notice but unmistakably there, a soft reminder that the atmosphere is always alive with chemistry, always in motion, always quietly doing its work. And far overhead, at the very edge of the upper atmosphere, the solar wind, a stream of charged particles flowing outward from the sun at hundreds of miles per second, brushes against the Earth's magnetic field and is deflected, funneled toward the poles where it creates the aurora borealis in the north and the aurora australis in the south. Curtains and ribbons of green and pink and white light rippling silently across the polar skies, like the Earth's own private display of something too large and too ancient to be called anything other than beautiful. The Earth's magnetic field, the invisible force that makes compasses work and protects us from the solar wind, is generated by the movement of molten iron in the Earth's outer core, thousands of miles beneath the surface. The core is hot, unimaginably hot, left over from the heat of the Earth's formation and supplemented by the decay of radioactive elements deep inside. The temperature at the very center of the Earth is thought to be roughly similar to the surface of the Sun, around 5,000 degrees Celsius, though we have never been there and can only infer it from the behavior of seismic waves and from our understanding of physics and chemistry at extreme pressures. This enormous heat drives convection in the liquid outer core, setting iron currents moving in great slow loops that generate electrical currents. And those electrical currents generate the magnetic field that deflects the solar wind and keeps the atmosphere from being slowly stripped away into space, the way the atmosphere of Mars was slowly stripped away after its own core cooled and its magnetic field faded. We are protected, constantly and silently, by the heat of the Earth's interior, by the quiet churning of liquid iron thousands of miles below where we sleep. It is another of those deep, invisible rhythms keeping us safe without our knowledge or our gratitude, faithful and steady, and so old that the rocks themselves can barely remember when it began. Now, as the night deepens, the world outside has grown very still. The birds that sang at dusk have found their roosting places, tucked into the dense foliage of a hedge, huddled along the sheltered underside of a branch, settled into a cavity in an old tree. Their body temperature has dropped slightly, their heart rates have slowed, their metabolisms have eased into the slower gear of avian sleep. Birds sleep differently from mammals in some ways. Many species sleep with one eye open, one hemisphere of the brain maintaining a kind of watchful half-alertness, while the other hemisphere rests, a trick called unihemispheric slow-wave sleep that allows them to rest while still monitoring for predators. Ducks sleeping in a row will often have the birds at the ends of the row sleeping in this one-eye open way, with the outer eye facing away from the group, while the birds in the middle can afford to sleep with both eyes closed and both hemispheres resting. Even in sleep, birds maintain a kind of social arrangement, a division of labor that keeps the group safe. There is something touching about this. The community organizing itself for rest, making space for each other to let go, taking turns at the gentle work of staying aware so that others may truly sleep. The mammals of the night are awake now, moving through the darkness with eyes that are better adapted to low light than ours, with noses that read the air with a precision our daylight-evolved senses cannot approach. The fox is trotting along the edge of a field, stopping and tilting its head, listening for the sound of movement beneath the snow or the dry grass, the ultrasonic rustle of a small mammal's passage. The owl is perched silently in a tree, its facial disc shaped to funnel sound into its ears with extraordinary precision. The asymmetrical placement of its ear openings allowing it to locate prey in 3 dimensions by sound alone, so accurately that barn owls can hunt in complete darkness if they need to. The hedgehog is rooting through the leaf litter at the base of a hedge, following the extraordinary chemical information of its nose through the dark world. All of these creatures are living their most fully alive moments right now, in the hours that seem empty and quiet to us, the hours we spend in sleep. The night is not empty. It is full of soft movement and subtle sound, and the patient, ancient business of eating and being eaten, of finding and being found, of life continuing in the dark the way it always has. The insects of the night are out as well, though in smaller numbers than the great buzzing abundance of a summer day. Moths navigate by the stars in ways that are still not fully understood, maintaining a fixed angle to a distant light source as a means of traveling in a straight line, a system that works perfectly when the light source is the moon or a star, but that leads to the circular spiraling we observe when moths encounter artificial lights, which are close enough that the angle changes as the moth moves, creating the impression of a curved path toward the source. There is something poignant in the confusion of the moth, its ancient navigation system deceived by something too new for evolution to have prepared it for, circling and circling in the warm glow of a porch light, following an instruction its body was given a very long time ago, when the only lights available were the ones far enough away that the angle stayed constant. It is a reminder that the biological rhythms and navigational systems built into living creatures were calibrated for a world before our own, a world of unbroken darkness at night, of stars and moon as the only sources of light, and that this older world is still the world that most of the living biosphere is designed for and depends upon. The darkness of a truly dark night, the kind of darkness you find far from any city on a clear night with no moon, is a kind of environment in itself. In that darkness, the Milky Way is visible, a broad river of soft light arching across the sky, the combined glow of 200 billion stars, too faint to see individually, but bright enough collectively to cast a very faint shadow on a white surface. For most of human history, every person on Earth saw this sky every clear night of their lives. The Milky Way was not a rare spectacle, but a constant presence, as familiar as the sun or the moon, woven into the mythology and the navigation and the calendar of every human culture that has ever existed. Today, roughly a third of the human population can no longer see the Milky Way from where they live, obscured by the glow of artificial light scattered back from the atmosphere. But it is still there. It has always been there. The same river of stars that our ancestors navigated by and dreamed about and told stories of is still turning slowly overhead every night, faithful and permanent, utterly indifferent to whether we can see it or not. The Milky Way itself is a rhythm, a vast, slow rotation of hundreds of billions of stars around a common center, taking somewhere between 200 and 250 million years to complete one revolution. Our solar system, sitting roughly 26,000 light-years from the galactic center, is moving at about 500,000 miles per hour in its orbit around the galaxy. And yet, from here, from the surface of this small planet, the galactic center is just a slightly brighter patch in the constellation Sagittarius, a soft smudge of ancient light that you can see on a dark summer night if you look to the south. The entire observable universe is full of this kind of motion. Galaxies rotating, galaxy clusters moving in streams, the universe itself still expanding from the moment of its beginning. Everything in motion, everything in a rhythm too large and too slow for any individual or any civilization to perceive. And yet, here we are, inside all of it, turning with the Earth and orbiting with the solar system and drifting with the galaxy, part of the vast, wheeling, interconnected motion of everything, resting peacefully inside a movement so enormous that it registers, from where we lie, as perfect stillness. Let yourself feel that stillness now. Let it settle around you and through you, the stillness that is not the absence of motion but its completion, the point at which all the great turnings and revolvings and orbitings add up to this one moment of quiet in your body and your mind. Everything is moving. Nothing feels like it is moving. And in that paradox is a peace that needs no explanation. The water cycle has been running continuously for most of the Earth's 4.5 billion year history. Water falls from the sky and collects in rivers and lakes, soaks into the soil and is drawn up by roots, filters slowly through rock layers to emerge as springs and wells, flows into the ocean, and is evaporated by the sun and carried by the wind back over the land to fall as rain again. This same water has been cycling through these same stages since the oceans first formed. The water in your body tonight has been part of this cycle for longer than complex life has existed on Earth. Some of it fell as rain over mountain ranges that no longer exist. Some of it was part of the deep ocean during eras when the continents were arranged so differently that a map of the world would be unrecognizable. Some of it was locked in polar ice during ice ages and released as the climate warmed. All of it has been cycling, 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 through sky and soil and sea and living thing, in the most continuous and uninterrupted recycling project in the history of the planet. There is something deeply comforting in the idea that the water in your body has been moving through this world for billions of years, that it has been part of countless forms of life and countless weathers and countless landscapes, and that it will continue cycling long after your own use of it is complete, passing into the soil, and then into a plant, and then into the air, and then into rain, and then into the ocean, and then into the air again. Nothing is lost. The water just keeps moving. The rhythm just keeps going. You are a temporary dwelling place for something that has been on a much longer journey than yours, and it will return to that journey when you are done with it. And that is not a melancholy thought, but a gentle one. You are part of something that does not end. Rain itself is a sound that has been reliably bringing sleep to mammals for as long as mammals have existed. The patter of rain on leaves, on soil, on the surface of a lake is among the oldest sounds in the living world, and the bodies of sleeping creatures have been lulled by it for hundreds of millions of years. The sound falls into a category that researchers sometimes call pink noise. Not pure white noise, which contains equal energy at all frequencies, but a more natural sound in which lower frequencies carry more energy, softer and deeper, more like the sounds produced by wind and water and the rustling of trees than the artificial sounds produced by machines. The brain, at rest, responds to this kind of sound by quieting itself, by settling into slower brainwave patterns, by reducing the vigilance that light and sharp sounds maintain during the waking hours. The sound of rain is the sound of safety, the sound of the world proceeding as it always has, the sound that says nothing unusual is happening. Everything is as it should be. You can let go. The sound of a river, moving steadily and without hurry over rounded stones, is another of these ancient sounds of reassurance. Rivers have been in their current courses, many of them, for thousands of years, some for millions, slowly carving their channels into the bedrock, smoothing the stones of their beds until they are as round and as polished as anything deliberately shaped by human hands. The smoothness of a river stone is a record of the time the river has spent working on it. The endless, small abrasions of water and sand and other stones gradually removing every irregularity, every sharp edge, every remnant of the angular fracture surfaces that the stone had when it was first broken from the bedrock. A very smooth stone in a fast river might have been there for 10,000 years, or 100,000 years, or longer. Patient, unhurried, slowly becoming more itself, more simply and completely a smooth stone, through the continuous, gentle, patient action of the moving water. The mountains that feed those rivers are themselves in a slow rhythm of rising and eroding. Mountain ranges form when tectonic plates collide, the collision forcing the crust upward in great crumpled folds that can rise many miles above sea level over millions of years. The Himalayas, the tallest range on Earth today, are still rising by a few millimeters each year as the Indian subcontinent continues its slow collision with the rest of Asia. A collision that has been underway for about 50 million years and shows no immediate signs of stopping. Meanwhile, the rain and the frost and the wind are working continuously at the surface of those mountains, wearing them slowly down grain by grain, carrying the eroded material into the rivers and eventually into the sea. There is a kind of balance in this, a dynamic equilibrium between the forces that build mountains and the forces that wear them away, so that the height of a mountain range at any given moment reflects the balance between the speed of uplift and the speed of erosion. Every mountain range that has ever existed has eventually been eroded to a plain, and the material of those ancient mountains is now the sedimentary rock of distant continents, waiting to be uplifted again in the next chapter of the cycle. The oldest rocks on Earth are a little over 4 billion years old, found in a few ancient geological terrains in Canada and Greenland and Australia, rocks so old that they predate the existence of any multicellular life, so old that the atmosphere was different when they formed, lacking the oxygen we breathe, full instead of nitrogen and carbon dioxide and trace gases. To hold one of these ancient rocks would be to hold something that was already old, when the first single-celled organisms were beginning to metabolize and reproduce in the warm, shallow seas of the early Earth. It would be to hold something that has been sitting on or near the surface of this planet for a time so long that every other aspect of the world, the oceans, the atmosphere, the continents, the living biosphere, has completely transformed around it, multiple times over. And yet the rock endures, slowly wearing away, slowly giving up its substance to the rivers and the sea, patiently participating in the cycle at the pace of deep time. Volcanoes are part of the cycle too, in their dramatic and earthly way. They are not random explosions, but the surface expressions of deep planetary processes, the venting of heat and gas from the interior, the refreshing of the atmosphere with water vapor and carbon dioxide that has been locked in the mantle, the building of new land at the edges and the middles of tectonic plates. Without volcanic activity over billions of years, the atmosphere would gradually have lost its carbon dioxide as it was absorbed by silicate rocks in a process called silicate weathering. And without carbon dioxide, there would be no greenhouse effect. And without the greenhouse effect, the Earth's average temperature would drop below the freezing point of water, and the oceans would freeze. It is the slow, geological cycling of carbon from the atmosphere into rocks and back into the atmosphere through volcanic emissions that has kept the Earth's temperature roughly stable over billions of years. A kind of geological thermostat that has allowed liquid water and life to persist through the eons. The volcanoes that seem so violent and destructive are, over geological time, the gentle breath of a living planet, exhaling the gases that make the world habitable. The deep ocean floor, where the pressure is crushing and the temperature just above freezing, and the darkness is absolute, is covered in a soft sediment of clay and the tiny skeletal remains of microscopic organisms called foraminifera and coccolithophores and diatoms, which lived in the sunlit surface waters, and when they died sank slowly down through the entire depth of the ocean to the floor, settling at a rate of perhaps a few centimeters per 1,000 years. These sediments record, in extraordinary detail, the history of the climate of the surface ocean over millions of years. The temperature of the water, the acidity, the amount of oxygen dissolved in the deep, the composition of the atmosphere above. By drilling cores from these sediments and analyzing the chemistry of the tiny shells layer by layer, scientists have been able to read a detailed history of the Earth's climate going back tens of millions of years, revealing the regular rhythms of ice ages and warm periods, the slow dance of carbon dioxide levels and global temperature, the long, patient heartbeat of the climate system as it has responded to the regular variations in the Earth's orbit and tilt, called Milankovitch cycles. These orbital cycles, changes in the shape of the Earth's orbit around the Sun, in the tilt of the Earth's axis, and in the direction the axis points, recur on timescales of roughly 20,000, 40,000, and 100,000 years, and they gently modulate the amount and distribution of sunlight the Earth receives in a way that, amplified by feedbacks in the climate system, has driven the regular alternation of ice ages and interglacials for at least the last 2.5 million years. We are currently in an interglacial, a warm period between ice ages, that began about 11,000 years ago, as the great ice sheets that once covered much of North America and northern Europe gradually melted back. The rhythms of ice and warmth are so old and so regular that they feel inevitable. Inevitable in the way that the turning of the seasons feels inevitable. Not surprising, not threatening, just the natural pulsing of a system too large for any individual to fully comprehend, but too regular for anyone to doubt. The ice itself, where it still exists on the high mountains and in the polar regions, is a kind of library. Each year's snowfall compresses the snow below it into ice, trapping tiny bubbles of air that were part of the atmosphere at the moment of trapping. Drill deep into the ice of Antarctica or Greenland, and you can extract these bubbles and analyze the ancient air inside them, measuring the concentrations of greenhouse gases from hundreds of thousands of years ago with remarkable precision. The ice cores from Antarctica have allowed scientists to reconstruct the composition of the atmosphere going back 800,000 years, through 8 complete cycles of ice age and interglacial, and what they found confirmed the close relationship between carbon dioxide levels and temperature that theory had predicted. Not perfectly, not simply, but unmistakably, the chemistry of the atmosphere and the temperature of the climate moving together through those long, slow cycles like partners in a dance so slow that a single step might take 1,000 years. The poles themselves have a rhythm of light and darkness that is different from anywhere else on Earth. At the geographic North Pole, the sun rises once a year, on the spring equinox in late March, and then circles slowly around the horizon, rising a little higher each day for about 3 months, reaching its maximum height on the summer solstice in late June, then sinking back toward the horizon and setting again on the autumn equinox, disappearing below the horizon for another 6 months of continuous darkness. It is the most extreme version of the day-night cycle, stretched to the length of a year, and the animals and plants of the polar regions have adapted their biology to this extreme rhythm, just as thoroughly as creatures in temperate zones have adapted to the rhythm of shorter days and longer nights as the seasons change. The Arctic poppy, one of the flowering plants that manages to survive near the edge of the polar zone, tracks the sun with its petals even in the continuous summer daylight, turning to face the sun as it moves around the sky, the way a sunflower does in lower latitudes, maximizing the warmth captured in its cup-shaped flower and thereby keeping its reproductive parts a few degrees warmer than the surrounding air, warm enough for insects to visit and pollinate. The migrations of birds are one of the great seasonal rhythms of the living world. Every autumn, billions of birds across the northern hemisphere abandon their breeding grounds and fly south, following routes that in some cases have been in use for hundreds of thousands of years. Routes that in many cases are encoded in the bird's genetics rather than learned, so that a young bird making its first migration can navigate successfully to a wintering ground it has never seen, guided by an internal map and compass that refers to the stars, to the Earth's magnetic field, to the sun's position in the sky, and perhaps to odors and sounds we have not yet identified. A barn swallow leaving its nest in the English countryside in September will fly 8,000 miles to southern Africa, crossing the Sahara Desert and the equatorial forests and the dry savannas, arriving at a destination it has perhaps been to before, but perhaps has never seen, and then in spring it will turn around and fly all the way back. The same individual bird may make this journey 10 or 20 times in its life, and each time it arrives back at the same farm, the same barn, sometimes the same nest. The reliability of this seasonal rhythm is extraordinary. The swallows arrive in spring in Europe within a week or two of the same date every year, so reliably that medieval Europeans believed their winter disappearance was explained by hibernation in the mud at the bottom of ponds, unable to imagine that a creature so small could travel so impossibly far and return so precisely. The salmon's journey is a rhythm of a different kind, less regular in time but equally precise in space. A Pacific salmon hatches in a cold, clear stream in the mountains, lives there for a year or two, and then undergoes a profound physiological transformation that allows it to move from fresh water into salt water, and it swims down the river and out into the ocean, where it will spend several years growing and feeding in the open sea, sometimes ranging thousands of miles from the river of its birth. Then, when the time is right, triggered by the length of the days, by the temperature of the water, by internal biological signals we still do not fully understand, it stops eating and turns for home, navigating back across the open ocean to the mouth of the right river, then fighting its way upstream against the current, leaping the waterfalls, sometimes crossing hundreds of miles of river to reach the exact stretch of stream where it was born, where it will spawn and die. The body of the spawned salmon becomes food for the stream, its marine-derived nutrients fertilizing the stream insects that will feed the next generation of salmon fry, completing a cycle that links the deep ocean and the mountain forest in a single animal's life. The connection between the ocean and the forest through the bodies of salmon has been traced in careful chemical studies of the trees growing along salmon streams. Trees growing near streams with large salmon runs have been found to have marine-derived nitrogen in their wood. Nitrogen that came from the ocean was absorbed by the organisms that the salmon ate, was incorporated into the salmon's body, and was then transported hundreds of miles inland and deposited in the forest by the spawning and decomposing fish. Bears and eagles and ravens and otters drag salmon carcasses away from the stream, distributing the marine nutrients through the forest floor, where fungi and bacteria break them down and plants take them up. A tall Sitka spruce growing by a salmon stream in Alaska might have a significant fraction of its carbon and nitrogen derived from the ocean. Cycled through the body of a fish that died a century ago, absorbed by a previous generation of trees, and then cycling through the trees and the soil and the water and back to the stream again, endlessly. The forest and the ocean are not separate. They are connected by the salmon and by the rain and by the rivers, and by 1,000 other threads and cycles that we are still in the process of discovering. The tides come in twice a day along most of the world's coastlines, and the timing is not exactly every 12 hours, but roughly every 12 hours and 25 minutes, because the moon is moving in its orbit even as the Earth is turning beneath it. So each high tide comes a little later than the one before, tracking the moon's position in the sky. Animals that live in the intertidal zone, the barnacles and mussels and starfish and hermit crabs and sea anemones that live on rocks between the high and low tide lines, have their body clocks synchronized not to the 24-hour day, but to this tidal rhythm, the roughly 12.5-hour cycle of the moon's pull. Their feeding and spawning and all the other activities of life are timed to the tides, not to the sun, so that they are active when the water is present to bring them food and to carry their larvae away, and sheltered and still when the water retreats and leaves them exposed to the air and the sun. In a laboratory, isolated from any tidal cues, many intertidal animals maintain their tidal rhythms for days, evidence that the tidal clock, like the circadian clock, is internalized in the biology, not merely a response to immediate external conditions. The highest tides of all occur when the sun and the moon are aligned, either both on the same side of the Earth or on opposite sides, so that their gravitational pulls reinforce each other. These spring tides, the word here has nothing to do with the season but comes from an Old Norse word meaning to jump or leap, occur twice each month, at new moon and full moon, and they are the tides that most dramatically define the intertidal zone, reaching higher up the shore and withdrawing further down than ordinary tides do. The lowest point of the extreme low tide exposes parts of the rocky shore that are almost never accessible, revealing communities of organisms that spend most of their lives below the surface, creatures that are rarely, if ever, seen by any creature that breathes air. Biologists will wait for these extreme spring low tides, sometimes occurring only a few times a year, to study the hidden life of the lowest intertidal zone. Creatures living in permanent semi-darkness, adapted to a world of cold water and reduced light, conducting their slow lives in the brief intervals between one covering of the tide and the next. The rhythm of flowering and fruiting in plants is tied to the length of the day in ways that are surprisingly precise. Many plants flower only when the days are shorter than a certain length, using the duration of darkness as a signal that winter is coming, and that seeds produced now will have the best chance of germinating next spring. Others flower only when the days are long, using the extended daylight of summer as their cue. Still, others are triggered not by day length at all, but by a period of cold, so that a seed or a bulb that has been exposed to winter temperatures will know that winter has passed, and that the spring warmth following the cold can be trusted as a real spring, and not just a warm spell in autumn. This process, called vernalization, ensures that plants do not flower too early in response to a warm autumn day, only to be killed by subsequent frost. The plant is not guessing. It is reading the reliable, long-term signals of the seasons and responding to them with the precision of 1 billion years of evolutionary refinement. The cherry blossoms of Japan are celebrated every spring with festivals and picnics, and a deep cultural reverence that has roots stretching back 1,000 years or more. The blooming of cherry trees is such a precise and regular event that phenologists, scientists who study the timing of natural events, have been able to use historical records of cherry blossom festivals in Kyoto, some stretching back to the 9th century, to reconstruct the climate history of Japan over more than 1,000 years. Because the date of the blossoms is so closely tied to the temperature of the spring that changes in the date of flowering reflect changes in the climate. In recent decades, the blossoms have been appearing earlier and earlier, the trees responding to the warmer springs of a changing climate. But the response itself, the tight coupling between the plant's biology and the temperature of the season, is ancient and precise, a rhythm that the trees have been keeping faithfully for as long as cherry trees have existed. The dawn chorus, the great outpouring of birdsong in the hour before and after sunrise, is one of the most beautiful of all natural rhythms. It begins before the light is strong enough to see by, 30 to 45 minutes before sunrise in the spring and summer, with the earliest risers, the robins and blackbirds, beginning to sing in the darkness. As the light gradually brightens, more species join in, each beginning at a particular light threshold that is characteristic of that species, so that the order of entry into the chorus is approximately constant from one day to the next and from 1 year to the next. At the peak of the chorus, in the heart of the breeding season on a clear May morning, the sound can be extraordinarily complex. Dozens of species all singing simultaneously, each voice distinct, each song a highly structured signal designed to attract mates and deter rival males, filling the air from the ground to the top of the tallest trees. And then, as the light continues to grow, and the morning wears on, and the work of foraging begins to compete with the work of singing, the chorus gradually fades, leaving the quieter, more sporadic singing of individuals going about their separate days. It has been suggested that the dawn chorus serves not only social and reproductive functions, but also something like a daily ritual of orientation. Each individual reestablishing its position in the acoustic landscape of the territory, confirming that it is present and healthy and in command of its space before the day begins. The sound of the forest on a calm summer night is almost entirely different from the dawn chorus. A much quieter, more sparsely distributed set of sounds, the occasional call of a nightjar or an owl, the soft chirring of crickets and katydids and other insects that have their own biological clocks set to the darkness. Crickets and katydids call by rubbing their wings or legs together in a process called stridulation, and the rate at which a cricket chirps is so closely tied to temperature that a naturalist named Amos Dolbear proposed a formula in 1897, now known as Dolbear's Law, for calculating the temperature in Fahrenheit from the number of cricket chirps per minute. It works surprisingly well as an approximation. Count the number of chirps in 14 seconds and add 40, and you have a rough approximation of the current temperature in Fahrenheit. The cricket does not know it is thermometer. It is simply following the chemistry of its muscles, which contract faster in the warmth and slower in the cold, and the rate of its calling reflects the rate of those contractions. But the result is a real relationship between the cricket's song and the temperature of the night. A small, intimate expression of the deeper relationship between the living world and the physical conditions it inhabits. The fireflies, blinking in meadows on summer evenings, are communicating in a language of light pulses, each species with its own characteristic pattern. The duration of the flash, the interval between flashes, the height above the ground, the flight pattern, so that females resting in the grass can identify males of their own species by the code of their lights and respond with their own flash at a precise interval after the males. Different species have different codes, and in places where many species of firefly coexist, they all flash simultaneously in a meadow, creating a complex and beautiful display of signals, crossing and interspersing without confusion, each individual searching the darkness for the specific pattern that means home. In some species of firefly in Southeast Asia, the males in a tree will begin to synchronize their flashing, gradually falling into unison until entire trees are pulsing together in perfect synchrony. The synchronization spreading from tree to tree until a whole riverbank is flashing in perfect unison. A spontaneous emergence of order from the independent blinking of thousands of individuals, each one adjusting its own rhythm in response to the flashes it sees around it, until the whole becomes greater than the sum of its parts. The phenomenon of synchronization, of independent rhythms falling into step with one another, is one of the most beautiful and surprising themes in all of natural rhythm. It appears in fireflies and in the applause of a concert audience, in the swinging of pendulum clocks mounted on the same wall, in the firing of pacemaker cells in the heart, in the synchronized flashing of neurons during certain brain states. When oscillating systems are weakly coupled, when they can influence each other just a little, they tend, in many circumstances, to synchronize, to pull each other into a common rhythm. This tendency seems to be built into the mathematics of coupled oscillators in a fundamental way, a consequence of the way periodic systems interact, and its appearance everywhere in the natural world from the microscopic to the cosmic suggests that synchronization is one of the deep principles of how rhythms behave when they are in proximity to each other. Even you, lying still right now, are participating in this. Your breathing and your heartbeat are in a loose synchrony with each other, the breath and the heart having found a comfortable relationship through the autonomic nervous system, each influencing the other in subtle ways that keep them coordinated without any conscious coordination required. The tides of the atmosphere, though much weaker than the tides of the ocean, are real. The gravitational pull of the sun and moon creates a very slight bulge in the atmosphere, a tidal wave of air pressure that moves around the earth following the sun and moon, too small to feel but measurable by sensitive barometers. There is also a much stronger atmospheric tide, driven not by gravity, but by heat. The differential warming of the day and night sides of the atmosphere by the sun creates a pressure wave that propagates around the Earth twice a day at the speed of sound, so well known to atmospheric scientists that it is called the atmospheric solar semi-diurnal tide. It is responsible for the regular twice-daily variation in atmospheric pressure that has been measured at weather stations around the world for centuries. The slight rise in pressure in mid-morning and mid-evening that appears in barograph records as a gentle, regular wave superimposed on the larger and more variable weather-driven pressure changes. It is the pulse of the atmosphere, the very slow, very gentle heartbeat of the air. The oceans also have their own internal tides, vertical oscillations of the thermocline, the boundary between the warm surface water and the cold, deep water, driven by the gravitational pull of the moon and the sun. These internal tides are much larger in amplitude than the surface tides they accompany. They can move the thermocline up and down by tens of meters in a single tidal cycle. And they play an important role in mixing the deep and shallow waters of the ocean, bringing nutrients from the deep up into the sunlit surface layer where photosynthesis can occur, and feeding the base of the ocean food web. They are mostly invisible from the surface, occurring hundreds of meters below, in the cold, dark interior ocean. But their effects ripple up through the food web to the surface in the form of enhanced biological productivity, and sometimes in the appearance of unusually cold, nutrient-rich water in unexpected places. The whole ocean surface is moving right now, not just in the local motions of wind-driven waves, but in great basin-scale currents that circle the major ocean basins in patterns called gyres. The North Atlantic gyre rotates clockwise, carrying warm, salty water northward along the western boundary of the basin in the Gulf Stream, and returning cooler water southward along the eastern boundary. The center of the gyre is a region of relative calm, with little wind and little nutrient upwelling, and its surface water is extremely clear and blue. The Sargasso Sea, famous for its floating mats of brown sargassum seaweed and for being the breeding ground of European and American eels, which travel to the Sargasso to spawn, and then, as larvae, drift back across the Atlantic to the rivers of Europe and North America, where they will spend their adult lives. The eel's migration, like the salmon's, is a rhythm that connects distant parts of the ocean and the land. A long thread of biological connectivity running through the salt water and the fresh water, and back again. The longest biological rhythms we know of in individual organisms are the cycles of certain plants that flower and then die after a single flowering event, sometimes after growing for many decades. The agave plants of the American Southwest are sometimes called century plants because of the popular belief that they live 100 years before flowering, though in reality most species flower after 10 to 30 years. The plant spends all of those years storing energy in its thick, water-filled leaves, slowly building the reserves it will need for a single, spectacular flowering event. A flower stalk that can grow 10 or 15 feet tall in just a few weeks, covered in blossoms that attract bats and insects and birds from miles around. After flowering and setting seed, the plant dies, its entire life's stored energy converted into the one act of reproduction. There is something deeply purposeful in this, something that resonates with the idea of life as a long, patient accumulation building toward a moment of release. A rhythm not of days or years, but of a lifetime, a single great cycle from birth through patient growth to the final flowering. The bamboo forests of China and elsewhere operate on an even longer cycle. Most species of bamboo are monocarpic. They grow vegetatively for many years or decades, then flower synchronously, all individuals of the same species in a region flowering at the same time, setting seed and dying together. The interval between flowering events in some species is 60 or even 120 years, so that in a human lifetime you might never see a bamboo of that species flower at all. And the synchronized mass, flowering, and die-off, when it comes, transforms thousands of acres of forest simultaneously, creating both an abundance of seeds and a famine of green bamboo that can have serious effects on the animals that depend on it, including giant pandas. Why bamboo has evolved this strategy of long-interval synchronous flowering is still debated among botanists. One theory is that by flooding the environment with seeds all at once, the plants overwhelm seed predators and ensure that enough seeds survive to germinate and establish new plants. Another is that the synchrony arose as a defense against pest insects. If every plant of a species flowers and dies at the same time, any insects specialized to feed on that bamboo starve when the plants die, and the next generation of bamboo grows up in an environment with few specialized predators. Whatever the reason, the result is a rhythm so long that it operates on a timescale outside ordinary human experience. A slow pulse of the forest that no individual human has ever witnessed in full. There are even longer rhythms in the living world, rhythms so slow that we can only reconstruct them from the fossil record and from the patterns of evolutionary change. The great mass extinctions, the 5 major events in the history of life when enormous percentages of species disappeared over geologically brief intervals, seem to have occurred with a certain rough regularity, approximately every 26 to 30 million years, according to some analyses of the fossil record, though the evidence for this periodicity is contested and the mechanism uncertain. Some researchers have proposed that the solar system's oscillation up and down through the plane of the Milky Way galaxy, a period of roughly 30 million years, might periodically expose the Earth to elevated cosmic ray flux or to clouds of cometary material, increasing the rate of impacts or other stressors on the biosphere. Whether this astronomical rhythm truly drives the periodicity of mass extinctions, or whether the apparent regularity is a statistical artifact is still being debated. But the idea is a beautiful one. The rhythm of life itself, at its grandest and most catastrophic scale, entrained to the oscillation of the solar system in the galaxy, the heartbeat of the Milky Way setting a tempo for the renewal of life on Earth. After each great extinction, life has recovered. This is perhaps the most important fact about the history of life on Earth, that it has always recovered, that the empty niches left by extinction are always eventually filled, that diversity rebuilds itself, that new forms of life emerge and diversify and fill the world with complexity again, in a rhythm of loss and renewal that has been repeating for more than 500 million years. The Earth, after the great end Permian extinction, 250 million years ago, the worst of all the mass extinctions, was nearly bare of complex animal life on land and in the shallow seas. And yet within 10 million years, an eye blink in geological time, the world was full of life again. Different life, new forms that had not existed before, the beginnings of the lineages that would eventually give rise to the dinosaurs and the mammals and, eventually, to us. Life is resilient in a way that exceeds anything we build or plan, because it operates on a time scale so vast that temporary catastrophe is just part of the rhythm, just a pause before the next chapter, just the deepest part of the exhale before the long, slow in-breath begins again. The moon's distance from the Earth changes over the course of its elliptical orbit. At perigee, its closest approach, the moon is about 30,000 kilometers closer than at apogee. Its farthest point, and the difference in apparent size is visible to careful observers. The full moon at perigee, sometimes called a supermoon by those who follow such things, appears somewhat larger and brighter than the full moon at apogee. The moon's orbit is not perfectly elliptical either. It is tugged and distorted by the sun's gravity and by the non-spherical shape of the Earth and by the cumulative gravitational effects of all the other planets, so that its perigee and apogee distances vary slightly from month to month and year to year. The moon's orbit has been the subject of some of the most exacting calculations in the history of astronomy, because its complexity served as a testing ground for the theories of motion and gravitation developed by Newton and those who followed him. To predict the moon's position accurately required a level of mathematical sophistication that pushed the boundaries of what was possible, and the astronomers who worked on the lunar problem for generations before the age of computers, filling notebooks with the results of hand calculations, building tables of corrections and subcorrections that accounted for every known perturbation, were engaging in some of the most meticulous intellectual work in human history. And yet the moon itself was unaware of all this attention, pursuing its patient orbit with perfect indifference to the centuries of calculation devoted to understanding it. The tidal forces of the moon on the Earth are gradually slowing the Earth's rotation. The friction of the ocean tides against the seafloor and the shorelines dissipates energy, taking it from the kinetic energy of the Earth's rotation and adding it, through the tidal bulge that the Earth's gravity maintains in the lunar orbit, to the moon's orbital energy. As a result, the moon is very slowly spiraling outward from the Earth, moving about 3.5 centimeters farther away each year, and the Earth's rotation is very slowly slowing, the day lengthening by about 2 milliseconds per century. This process has been going on for as long as the moon has existed, for approximately 4.5 billion years, which means that the early Earth was spinning much faster. The day in the Archean eon, when the first microbial life was arising in the oceans, may have been only 10 or 12 hours long. The moon itself was much closer then, much larger in the sky, raising enormous tides as it swept around the rapidly spinning Earth. Over billions of years, the dance of Earth and moon has slowed, and the gap between them has grown, and the rhythm of the day has lengthened from those ancient hours to the 24 hours of today, and will lengthen still over billions of years to come, until the Earth's rotation and the moon's orbital period are synchronized, and the moon hangs motionless above one face of the Earth while the other face never sees it at all. There is a rhythm in the way the light changes through the seasons that affects not just our bodies, but our moods, our energy, our sense of possibility. In the long days of summer, the light is different in quality as well as in quantity. The sun rises higher in the sky, casting shorter shadows and more direct light, and the blue sky scatters that light across the whole atmosphere, so that even the shadows are not truly dark, but filled with the soft, diffuse blue of the scattered sky. The quality of light in summer is an awakening quality, a quality that has evolved organisms to associate with activity and growth. But the light of late autumn and winter is different. The sun low in the sky even at noon, the shadows long and blue, the light golden and warm in tone, slanting across the landscape in a way that makes everything seem older and quieter, and somehow more complete. There is a reason that so many painters and photographers have loved the light of autumn and winter. It is an interior light, a reflective light, a light that invites rest and contemplation rather than action. Your body responds to the quality of the light as well as its quantity, and the golden, slanting light of the late year is the light of rest, the light that tells your biology to slow down, to gather inward, to prepare for the longer darkness ahead. In the darkness right now, there are things happening that depend on the dark to happen at all. The migration of moths and other nocturnal insects depends on the darkness for navigation. The hunting of owls and other nocturnal predators depends on the darkness for concealment. The pollination of night-blooming flowers, moonflowers and night-blooming jasmine, and the queen of the night cactus, which opens its extraordinary white blooms for only a single night each year, depends on the darkness to attract the moths and bats that carry their pollen. The darkness is not merely the absence of light. It is an environment with its own ecology, its own cast of characters, its own rhythms and interactions and dependencies. The living world needs the dark as much as it needs the light, and the reliability of the dark, the certainty that every day the light will fade and the darkness will come, is as fundamental to the ecology of the planet as the certainty that every night the darkness will give way to light again. The stars that are rising in the east right now are the same stars that were rising in the east at this time of night exactly a year ago, and a century ago, and 1,000 years ago. The sky is repeating itself with extraordinary faithfulness. The same stars rising and setting in the same order, night after night, year after year, century after century. The constancy of the sky has been one of the deepest sources of comfort and orientation in human experience. In a world where almost everything changes, where people are born and die, and societies rise and fall, and landscapes are transformed, the stars remain. The same Orion that hung above the ancient Egyptians as they built the pyramids hangs above the same patch of sky tonight. The same 3 stars in the same belt, the same reddish Betelgeuse at the shoulder, and the same blue-white Rigel at the foot. The same 4 stars of the great rectangle. The sky connects us, silently and without effort, to every human being who has ever looked up at night and felt the same quiet wonder at the constancy of something so vast. The wind tonight, if there is wind, is part of the larger breathing of the atmosphere. Air moving from a region of high pressure to a region of lower pressure, following the gradient in a way that is simple in principle but complex in practice, because the Coriolis effect of the Earth's rotation deflects the moving air to the right in the northern hemisphere and to the left in the southern hemisphere, creating the spiral patterns of highs and lows that weather maps show as circular arrows. A high-pressure system is air that has descended from higher in the atmosphere and spreads outward at the surface, flowing clockwise in the northern hemisphere, anticyclonically in a gentle spiral that tends to bring clear, calm weather. A low-pressure system is air converging at the surface and rising, flowing counterclockwise in the northern hemisphere, and it is in the rising air of low-pressure systems that the clouds and rain of storms develop, as the rising air cools and the water vapor in it condenses into droplets. The weather is a rhythm of highs and lows, calms and storms, clear spells and rainy periods, driven by the unequal distribution of heat across the surface of the Earth and the constant efforts of the atmosphere to redistribute that heat and achieve a balance that it never quite reaches, because the sun keeps providing new energy, and the day and night cycle keeps creating new imbalances. And so the atmosphere keeps moving, and the weather keeps changing in its irregular but not entirely unpredictable way. Somewhere in the world right now, a thunderstorm is occurring. In fact, at any given moment, there are estimated to be roughly 2,000 thunderstorms in progress somewhere on the Earth's surface, and together they generate about 100 lightning strikes per second. All of this electrical activity connects the atmosphere to the ground in a way that maintains a global electrical circuit. The Earth's surface carries a small negative charge, and the ionosphere at the top of the atmosphere carries a small positive charge, and the difference between them is maintained partly by the continuous charging of the atmosphere by lightning, and partly by the continuous gentle flow of electrical current from the ionosphere down through the fair weather atmosphere to the ground in the quiet regions between storms. It is a circuit in the truest sense, a closed loop of electrical charge flowing in one direction through the storm regions, and in the opposite direction through the fair weather regions, maintaining the electrical potential of the atmosphere in a kind of dynamic equilibrium. We are always, in a quiet and invisible way, inside this global electrical circuit, part of the Earth's own electromagnetic rhythm. The magnetic field of the Earth is not constant, but fluctuates in ways both rapid and slow. On the time scale of seconds to years, the field varies due to the influence of the solar wind, to currents in the ionosphere, and to the complex dynamics of the liquid iron core. These variations are recorded in detail by a global network of magnetic observatories and are important for navigation systems and for understanding the space weather environment. On the timescale of thousands to millions of years, the field undergoes much more dramatic variations, weakening and strengthening and occasionally reversing completely, so that what is now north magnetic becomes south and vice versa. These polarity reversals, recorded in the magnetic signature of the oceanic crust as it was created at mid-ocean ridges and then spread outward over millions of years, provided some of the key evidence for the theory of plate tectonics in the 1960s, the pattern of alternating magnetic stripes on the seafloor, confirming that the seafloor was spreading symmetrically away from the mid-ocean ridges and recording the polarity of the field at the time of its formation. The last polarity reversal was about 780,000 years ago, and the timing of reversals over the past tens of millions of years is irregular, but suggests that another is not imminent. Though we would not know one was beginning until it was well underway, the process taking thousands of years to complete, and the field weakening significantly during the reversal. The rocks themselves remember the direction of the magnetic field when they were formed. When magma cools and solidifies, the magnetic minerals in the rock align themselves with the ambient magnetic field, and then are locked into place as the rock becomes solid. These ancient magnetic signatures, preserved in rocks ranging in age from a few thousand to hundreds of millions of years, provide a continuous record of the direction and intensity of the Earth's magnetic field through deep time. Paleomagnetic studies of ancient rocks have been used not only to track the history of the field's polarity reversals, but also to reconstruct the positions of the continents through the past several hundred million years, since the apparent direction to the magnetic pole as recorded in rocks of different ages from the same continent reflects the latitude of that continent at the time of the rock's formation. Plotting the apparent polar paths from rocks of different continents showed that they were inconsistent with a fixed continent, but could be reconciled if the continents had moved relative to each other. One of the lines of evidence that helped establish the revolutionary understanding that the surface of the Earth is not fixed, but is divided into plates that have been slowly moving, colliding, and separating for at least 3 billion years. The movement of the tectonic plates is driven ultimately by the heat escaping from the interior of the Earth, the same heat that maintains the fluid outer core and generates the magnetic field. Where the plates move apart, as they do along the mid-ocean ridges, hot mantle material wells up to fill the gap, melting to produce basaltic magma that erupts as new seafloor. Where the plates converge, one plate typically dives beneath the other in the process of subduction, sinking back into the mantle and carrying with it a load of sediment and seawater and carbonates that are transformed at depth and eventually recycled back to the surface through volcanic activity. The whole cycle of the creation and destruction of oceanic crust, from formation at a mid-ocean ridge to subduction at a trench, takes roughly 100 to 200 million years. So, the oldest oceanic crust on Earth today is only about 200 million years old, much younger than the oldest continental rocks. The oceans are being continuously renewed, their floors slowly replaced by fresh magma, their chemistry maintained by the continuous exchange between seawater and the hot rock of the seafloor. The forests of the earth breathe carbon dioxide in and oxygen out during the day, through the photosynthesis in their leaves, and breathe oxygen in and carbon dioxide out at night, through respiration. But over the whole year, in a healthy forest, the balance is slightly tipped toward the absorption of carbon dioxide from the atmosphere. The forest is a net carbon sink, slowly storing carbon in wood and soil. This has been happening on a large scale for several 100 million years, since the great coal forests of the Carboniferous period, when the capacity of fungi to break down lignin, the tough structural polymer of wood, had not yet evolved to keep pace with the rate of wood production, and vast quantities of organic carbon were buried in swampy soils before it could be decomposed, eventually becoming the coal seams that powered the Industrial Revolution. The burial of all that carbon reduced the carbon dioxide concentration of the atmosphere significantly, cooling the climate and contributing to an ice age that covered much of the southern hemisphere with glaciers 300 million years ago. And then the burning of that same carbon over the past few centuries has returned it to the atmosphere, and the atmosphere is responding as it always does to an increase in greenhouse gases, by retaining a little more heat and warming the surface. The carbon cycle is a rhythm, a very long rhythm of burial and return, and we have interrupted that rhythm by extracting and burning in a few centuries what was buried over tens of millions of years. But the planet has dealt with abrupt changes in carbon dioxide before. There have been times in the geological past when carbon dioxide concentrations were much higher than today, and times when they were much lower. The planet has been ice-covered pole to pole at least twice in its history, in what geologists call snowball Earth events, and it has been so warm that there was no polar ice at all, and forests grew near the Antarctic coast. These extreme states were followed by recoveries. The ice melted, the warmth faded, the balance shifted, always through the slow, patient action of geological processes, the weathering of rocks removing carbon from the atmosphere or volcanic activity adding it back, operating on timescales of millions of years. The Earth has a natural thermostat, though it is a thermostat that responds on geological rather than human timescales, a thermostat that keeps the planet habitable over the long run, but cannot prevent large swings in climate over periods of thousands to millions of years. The Earth will be fine in the long run. It has survived far worse. The question is only what the world will be like for the living things on its surface during the transition, and that is a question that belongs to a different kind of attention than the quiet, restful attention we are cultivating here. Here, in this quiet moment, it is enough just to rest inside the knowledge that the Earth has always managed to find a way, that the great cycles and rhythms of the living and geological world have a resilience and a staying power that no temporary disruption has permanently overcome. The living world is old. It has been here, in some form, for 3.5 billion years. It has seen every kind of catastrophe and every kind of recovery. It knows how to persist, and you are part of it, part of this ancient, rhythmic, resilient living world. A temporary but genuine expression of the same life that has been cycling through the biosphere since before complex cells existed. You carry in your DNA the accumulated wisdom of billions of years of evolution, the record of every ancestor that survived long enough to reproduce, all the way back to the first self-replicating molecule in the warm chemistry of the early Earth. You are the current expression of an immensely long and mostly successful story. And tonight, like every night, you are doing what every successful organism in that story has done. Resting, recovering, allowing the body to repair and consolidate and prepare for another day. The night is doing what it has always done. The darkness is doing its quiet work. The stars are continuing their ancient apparent journeys across the sky. The moon, wherever it is in its cycle tonight, is either visible or invisible, waxing or waning, but always there, always reliable, always pulling gently at the water in the oceans and the water in the soil and, in some small and unconfirmed way, perhaps at the water in the body. The forests outside are standing quietly in the dark, their leaves closed, their roots still drinking from the soil, their wood full of the chemical record of decades of seasons. The creatures of the night are about their business. The creatures of the day are resting, and the earth is turning, turning as it has always turned, carrying you gently through the dark and back toward the light, without hurry, without fail, with a reliability so perfect that it has become the foundation of all biological existence on this planet. You can feel this reliability if you allow yourself to. The weight of your body pressed into the surface beneath you is the weight of the Earth's gravity, the same force that holds the atmosphere in place and keeps the oceans from escaping into space and maintains the moon in its orbit. That downward pull, that gentle, insistent heaviness, is the planet holding you. It is not impersonal. It is the expression of the Earth's mass, a force that reaches out from every atom of the earth beneath you, and gently, persistently, steadily draws you down toward the center of the planet, toward the iron heart of the world. And the surface beneath you responds by pushing back equally, preventing your fall, creating the restful equilibrium of stillness that allows you to lie here without effort, supported, held, in the most ancient and fundamental embrace of all, the embrace of gravity and ground. Your breath is slowing now, or it has already slowed, or it is finding its own rhythm without your attention, as it always does. The muscles of your face are relaxed. The muscles of your shoulders have let go. The long muscles of your back are releasing their habitual tension. The muscles of your arms and hands have softened. Your body is remembering, as it does every night, how to be still. It is very good at this. It has been doing it for your entire life. The temperature of your skin is dropping slightly as your body relaxes and your core temperature begins its nighttime decline. The blood is moving inward toward the body's center, away from the extremities, part of the complex physiological choreography of sleep onset. Your eyes, closed now, are resting in darkness, and if you notice any images or thoughts arising behind them, they are only the surface froth of a mind beginning to let go. The last random activity of the day brain before the deep patterns of sleep come in to smooth it all away. These thoughts do not need your attention. They are just ripples on the surface of a lake that is becoming still. The lake becomes still from the outside in. The edges grow quiet first, where the water is shallow and the surface disturbances die away first. Then the middle, the deeper water, grows still, and eventually the whole surface is smooth, reflecting the sky, reflecting the stars if the sky is clear, a mirror of silence so perfect that it becomes, in a way, its own kind of sky, an inverted universe of starlight lying flat on the water in the dark. That is what your mind is doing now, growing still, growing smooth, becoming a surface that reflects the sky rather than generating its own disturbances. The morning will come. It always comes. The earth will carry you back around to face the sun. The light will return. The birds will sing their sequence from the first gray suggestion of dawn through the full, brilliant cascade of the chorus. And everything will begin again, refreshed, renewed, with you rested inside it. But that is for later. That is for the other side of this night. Right now, there is only this, the stillness, the dark, the warmth, the weight, the slow breath, the slow beating of the heart. The rivers are running in their channels. The tide is doing whatever it is doing, rising or falling or suspended at its turning point, that brief moment of slack water when the direction of flow reverses and the whole estuary pauses in a kind of held breath before the water begins to move the other way. The salmon are wherever they are in their journeys. The trees are standing in the dark. The stars are turning. The mountains are enduring. The deep ocean is circulating in its ancient, slow, dark patterns. All of it is here. All of it is continuous. All of it is part of the one great rhythm that has been turning since before the earth had a moon, since before the sun had planets, since before this particular corner of the galaxy had anything worth noticing in it at all. And you are resting at the center of it, not at the geographic center, not at the astronomical center, but at the only center that ever matters, the center of your own experience, the still point around which your own awareness turns. Quiet now, very quiet, sinking deeper with each breath. Each soft exhalation a small release. Each inhalation a gentle gathering of rest. There is nowhere to go. There is nothing to do. The night is long and soft and full of the quiet activity of a world that knows how to rest. Let yourself be part of it, not watching it, not thinking about it, just being inside it the way you have always been inside it, the way every living thing is inside it, woven into the fabric of the planet's rhythms by the chemistry of your cells and the architecture of your biology, and the long, patient inheritance of everything that lived before you and learned, as you are learning now, as you have always known, how to let the darkness do its work, how to trust the turning of the earth, how to give yourself over to the ancient, faithful, beautiful rhythm of the night. In the deep caves that exist beneath the limestone hills of many regions, there are formations of calcite called speleothems, stalactites hanging from the ceiling, and stalagmites rising from the floor, formed by the slow dripping of calcium-saturated water through the ages. These formations grow at an almost incomprehensibly slow rate, some as little as a cubic centimeter per century, and yet the largest of them have been growing for hundreds of thousands of years, layer upon layer of calcite deposited so slowly and so continuously that each ring of crystal records the chemistry of the water that dripped through it, and the chemistry of the water reflects the temperature and rainfall of the surface above, so that the speleothem becomes another kind of climate archive, another patient record keeper, another witness to the long rhythms of the earth's surface. In complete darkness, in silence broken only by the slow drip of water and the distant sound of an underground stream. These formations have been growing through ice ages and warm periods, through the entire span of human civilization, and far, far before it, following only the rhythm of water and chemistry and time. The underground rivers that feed those formations travel through a hidden world that most of us never see, dissolving the limestone as they flow, gradually enlarging their passages over thousands of years, sometimes dropping suddenly into darkness through holes in the cave floor, sometimes emerging as springs in the side of a hill miles from where they entered the ground. The water follows the path of least resistance through the rock, guided by the tiny cracks and bedding planes that were formed when the limestone was laid down as sediment on an ancient seafloor, following a map that was written millions of years ago in the arrangement of calcium carbonate shells on the floor of a warm, shallow tropical sea. Even the route the water takes through the underground is determined by deep time, by the history of the rock, by the slow, patient weathering of centuries of previous water flowing through the same passages. The underground is full of the record of the surface, as the surface is full of the record of the underground, and everything is connected, and everything keeps its rhythm in the dark. The soil microbes working beneath any meadow are following their own cycles of activity, more active when the soil is warm and moist, less active in cold and drought, responding to the same seasonal signals that animate the plants above them, so that the whole soil ecosystem pulses with the seasons, accelerating in spring and summer and slowing in autumn and winter, exhaling carbon dioxide when warm and active, drawing down nutrients and releasing them in cycles tied to the cycles of plant growth and root activity. The mycorrhizal fungi that thread their way through the soil and into the roots of most plants are operating a continuous exchange, delivering phosphorus and water to the plants they are connected to and receiving sugars in return, a trade that has been going on since plants first colonized the land more than 400 million years ago. The mycorrhizal network in a forest connects the roots of different trees, allowing carbon and nutrients to flow from one tree to another, the larger and more productive trees sometimes subsidizing the smaller and more shaded ones, a kind of underground sharing economy that is entirely invisible from the surface and entirely essential to the health of the forest. The forest floor, with its deep silence and its carpet of fallen leaves, is the surface of an immensely complex, ancient, and active system of exchange, a system that proceeds entirely without our awareness in the nights and the days while we go about the surface, lives we think of as the whole of things. The seasons change the light in ways that are deeply and wordlessly familiar to anyone who has lived through them. The particular quality of a November afternoon, the low golden light slanting across frost-stiffened grass, the long blue shadows stretching away from every vertical object, the clarity of the air after the leaves have fallen and the haze of summer evaporation is gone. All of this is a specific kind of light, a specific kind of season, and your body recognizes it at a level much deeper than thought. The cells in your skin are responding to the reduced ultraviolet radiation of winter sun. The photoreceptors in your eyes are processing the lower angle and the warmer color temperature of the winter light. The pineal gland is taking note of the shorter day length and adjusting the timing of melatonin release accordingly. You feel the season in your body before you think it with your mind, because the body has been living in seasons since long before the mind could name them, since long before your ancestors had words for the months or the solstices or the equinoxes. The seasons are written in the biology, and every autumn that arrives, every shortening of the days, every first cold night, is recognized not as something new, but as something deeply familiar, something your body has been expecting and preparing for since the summer peak. The equinox, the moment when the day and the night are of equal length, is a hinge point in the rhythm of the year. It has been observed and marked by human cultures all over the world since before recorded history, because it is one of the few moments when the geometry of the Earth's orbit and tilt produces a clearly defined and easily observed symmetry. The sun rising due east and setting due west. The day exactly 12 hours long everywhere on Earth. The noon sun casting its shadow exactly north or south, depending on which side of the equator you stand. The great megalithic monuments of prehistoric Europe, Stonehenge, Newgrange, the Callanish stones, are aligned to the solstices and equinoxes in ways that required centuries of careful observation to achieve. Generations of people watching the sky and marking where the sun rose and set at different times of year, building up a detailed knowledge of the solar calendar that was literally built in stone for the generations that came after. These monuments are the visible, enduring record of humanity's first serious engagement with the rhythms of the sun, the first evidence that we knew, consciously and deliberately, that we were living inside a rhythm, and that the rhythm could be measured and honored and passed on. Before the monuments, before any written record, before anything we could call civilization, human beings were already keeping time with the rhythms of the natural world, tracking the phases of the moon, noting the rising and setting points of stars, following the migrations of animals, monitoring the flowering of plants and the ripening of fruits, organizing their year around the cycles that determined when food would be available and when it would not. This was not primitive or unscientific. It was a sophisticated and deeply pragmatic engagement with the rhythmic structure of the natural world, an engagement that required careful observation over many years, that built up into a body of knowledge passed from generation to generation, that formed the basis of the relationship between human communities and the ecosystems they depended on. The natural rhythms were not just background. They were the framework of existence, the calendar and the clock, the whole structure of time within which human life was lived. We have not lost this connection, not entirely. It lives in us still, in the way we feel the seasons change, in the way we notice the shortening of the days in autumn, in the way we turn toward the light in spring, in the way we need the night to rest and the morning to begin again. Let go a little more with each breath. The thoughts grow lighter and further away. The sounds of the world grow softer, if there are sounds. The warmth of the blankets or the sheets or the comfortable weight of whatever covers you is real and present and enough. You are held. You are safe. The earth is turning. The stars are out. The night is doing exactly what the night has always done. And you are sleeping, or close to it, or drifting in the warm, shallow water just above sleep, where the mind is soft, and the thoughts are gentle, and the world is very far away. That is the right place to be. That is the place the body has been guiding you toward since the light faded hours ago, since the melatonin began its gentle tide, since the long day's work began its slow releasing. You are exactly where you are meant to be. Rest now. The morning will take care of itself. The sun will rise again without your help. The birds will know when to sing. The world will be there when you return to it. And it will have been turning all through your sleep, faithful and unhurried, carrying you through the dark on its slow, ancient arc, back toward the light. The earth turns, the night deepens, the silence grows, and you sink gently into it, like a stone settling through deep, still water, slowly, peacefully, with no resistance, toward the quiet and the dark, and the rest at the bottom of everything, where the great rhythms of the world move through you without disturbing you, where the turning of the planet is just a soft, deep hum beneath your stillness, where sleep is not something that happens to you but something you are, simply and completely, in the way that the river is water, and the forest is trees, and the night is dark, naturally and without effort, resting at the center of the turning world. Sleep well.